Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on how to solve quadratic inequalities for mathematics grade 11, a topic many find confusing because they tend to confuse inequalities with equations. The two may look identical, but they're not the same. And as such, you cannot take methods you use to solve equations and apply them on inequalities. They're different, and as such, you require different methods to do that. In this video, I'm going to show you all the tips and tricks on how not to confuse the two, and a step-by-step easy guide to help you solve any type of inequality, whether it is a standard basic one or one that is a special case. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on new videos we upload in the future. And if you have a question or would like to make a video request, please comment down below with the topic and grade you'd like me to cover, or alternatively send all that information to the contact details provided in the description box. Now back to the video. In detail, we're going to look at number one, the definition of a quadratic inequality and how that differs from a quadratic equation. Number two, we're going to look at steps on how to solve a quadratic inequality. And once you master the steps, no inequality will trouble you. You'll be able to solve any type of inequality once you master this step-by-step way. Number three, we're going to look at the first two examples, which are example 1 and 2, that will show you how you deal or solve an inequality, a quadratic inequality that is basic or standard. Like, this is the simplest you can find. No complications here, as easy as it comes. Number four, we're going to look at example 3, which will show you how you deal with an inequality that requires you to multiply out by a negative sign throughout, and how that changes the solution in the end. Number 5, we're going to look at example 4, which will show you how you solve a rational inequality and how the methods you use to do that are a little different from the methods we use to solve a rational equation. Number 6, we're going to look at example 5, which will show you how you solve rational inequalities that are of a special case. Number 7, we're going to look at example 6, which will show you how you deal with other special cases of inequalities that are not necessarily rational inequalities. We have a lot to cover, so let's start. Starting with the definition, a quadratic inequality is basically like a quadratic equation, but the only difference is that instead of an equal sign over here, separating your quadratic expression with your zero, you have instead a greater than sign, or a greater than or equal to sign, or a less than sign, or a less than or equal to sign instead of is equal sign. Now let's look at steps on how to solve inequalities. Step number 1, take everything to the left hand side. Once you do that, everything becomes clear. Number 2, factorize. And once you factorize, use those factors to find your critical values. That's step number 3. Number 4, draw up a table of signs, and I'm going to show you exactly how you do that. Or draw a simple basic parabola, or use both to help you figure out what the solution that applies to your particular inequality should be. And number 5, write that solution and present it on a number line. Not all cases will require you to present your answer on the number line, but in case where you are required to do so, I'll show you exactly how you use the number line in all of the examples. I'm going to show you how you present that into a number line. So whenever you are needed to use a number line to present a solution, you're able to do that without any issues or problems. Now let's look at the first example, that is example 1, and it says solve for x squared minus 5x plus 6 is greater than or equal to 0. This is one of your basic standard inequalities. No complications here. We already have everything on the left hand side and 0 on the right hand side. So what we do is we factorize. Step number 2. Step number 1, let's factorize. Let's factorize. So we factorize 2 sets of brackets. Notice how my inequality is still intact. Nothing has changed. Okay, the factors for 6 are 6 and 1, 3 and 2. The ones that will be the most applicable here is 3 and 2, because when you multiply them together, they should give you 6, and when you add them together, they should give you 5. Right. So we use 3 and 2. and negative signs, because when you multiply together they will give you a positive for the last term, and when you add them together they'll still give you a negative. And that's how you factorize that. If you need any help with factorization, especially factorizing quadratic inequalities or equations for that matter, I've already done a couple of videos on that, so go on the channel and use that to learn how to factorize. And now that you've factorize your quadratic expression, you use that to figure out what your critical values are. So step number 2, critical values in this case. The next step is finding your critical values. How do you do that? You basically take your factors and equate each and every one of them to 0, like you would in an equation, almost like solving. Basically, you're looking for roots that make this expression 0. So because that is your point of reference, let me put it that way. Those are points of reference that we need in this particular inequality and all inequalities to be able to figure out what the applicable solution should be. The second one gives us 3. So here are your critical values. The first one is 2 and the second one is 3. And what you do next is you draw up a table. And in that table, you make sure that you line up your critical values in ascending order. From the left-hand side, starting with the smallest on the left-hand side and ordering them to the right-hand side in order of ascending order. Now let's draw up the table. So you start with the factors that will give you the smallest critical value, and that's x minus 2 in this case. You line that up first. Try and do that because this helps to avoid confusion and complications when you're analyzing whatever it is that, and then the last one will be f of x. F of x is basically the product of the two, remember? F of x is simply equals to x minus 2. Now, because of space, I'm not going to write the whole thing. So understand that f of x means x minus 2 times x minus 3. And now, we draw regions. And I'll show you how that will work out. Okay, so let's separate all of this. And now what you do is you list your critical values in ascending order from the smallest to the biggest. So we start with 2 on the left hand side. There is your 2. Let me fix that, sorry. 2, and then the next one. Okay, let me fix that. And then the next one is 3. That's how you line them up. If there were more critical values, you will line them up that way to the right in that order of ascending order. All right, now you figure out where these critical values align with where your factors are 0. X minus 2 will be 0 at 2. We've already solved that. It's 0 at 2. So you put a 0 there to remind you that's where it is 0. X minus 3 will be 0 at 3. You're not sure what we mean by that. At 3, 3 minus 3, that gives you 0. And then at 2, 2 minus 2 will give you 0. Still, 2 minus 3 will give you something else. And we'll see how that works out and how we use that to figure out what the signs are throughout the table. All right, and now you go. What then happens with your f of x? Remember, f of x is simply the product of the two factors, x minus 2 times x minus 3. Now, when x minus 2 is 0, it does not matter what the other one is. Your f of x will be 0. In other words, when this is 0, it does not matter what this is. It can be anything, this one, but your product will be 0 nonetheless. Same thing for when x minus 3 is equals to 0. It does not matter what this is. When you multiply them together, you will get a 0. So our f of x will be 0 when x minus 2 is equals to 0 and when x minus 3 is equals to 0. Very important, because in some cases, you have a case where your f of x cannot be 0. Because one of the roots may be divided, and then one of the roots makes that undefined, and you put an x instead of a 0. You will see. We'll look at an example that is similar, but I just wanted to understand that it's not always the case where you get your f of x is equals to 0 in any case. Just be cognizant of that. And now what you do is now, if you prefer, draw up a simple quadratic function or a parabola. It will be simple. Here is a simple parabola that you can draw. Let me draw a simple parabola. Here is a simple parabola. simple parabola will be like this. Remember, f of x in the beginning was equal to, here is f of x in the beginning, it's x squared minus 5x plus 6, x squared minus 5x plus 6. Alright, your a is positive, it's equal to 1, it's positive, so that means your arms are going to look up. That is very important. Your y-intercept is 6, so your graph will cut the x-axis, the y-axis at 6. You can draw this, graph in a more elaborate manner, but it's really not necessary. You can simply just do it like this. You can simply draw your graph like this. It's going to point out, okay, and it will have two roots. It will have two roots over here, two roots over here. One on the left-hand side will be 2, and then the other side will be 3. So you've got the two roots. One is 2 on the left-hand side, and the other one is 3. So you don't have to put the axis in here as long as the x-axis is represented, so you know this, everything on top of the x-axis where you've got your roots is where your graph is positive, and anything below that is where your graph is negative. That's basically all you need to figure out. You can draw up an elaborate graph if you want to. This is for those people that don't necessarily master graphs, which again will do a video on as well. So even if you don't have to draw an elaborate graph, this is fine enough. So now you go back and you ask yourself on the table, where is this x minus 2 positive, where is it negative? We'll look at what happens when you've got a bigger value than 2, because this is where your 0 is. This is where you get your 0. X minus 2 is 0. What happens when you've got a number bigger than 2? Could be 3, could be 4. Let's make it 4 in this case. 4 minus 2 gives us 2, which is positive. So your graph to the right, on the right of the table, will be positive to the right of 2 for this particular factor. Very important. Now what happens to the left of 2? What happens when your x is anything less than 2, 1 or 0, for example? 1 minus 2 is equal to negative 1, which is negative. So it is negative to the left of 2. Same story over here. X minus 3 is 0 at 3. But when you've got your x bigger than 3, for example, 4 minus 3, that is equals to 1, which is positive. So it is positive to the right of 3. And to the left of 3, let's see what happens. Anything less than 3 could be 2, could be 1. Let's use 1. 1 minus 3 gives us negative 2, which is negative. So anything to the left of that is negative. We're done with the signs, and that's basically how easy it is. That's all you need to do. We just use those values to test and to make it easier for you to follow, but you don't really need to do all that. All right, now, how do you now figure out what the sign on the f of x is going to be? Remember, f of x was just the product between the two, right? X minus 2 times x minus 3. So what you do is with the signs, you follow the same pattern. Okay, so in the first one, the sign is, okay, in this region where x is greater than 3, right? In this region, your x minus 2 is positive, your x minus 3 is positive. So when you want to figure out what the sign of f of x in that region is, it's very easy. You just go, this is going to be positive, and that is going to be positive. You multiply the two positive times positive, that gives you positive. So to the right, that is positive. To the right, that is positive. Okay, let's use red. To the right, that is positive. Between 2 and 3 in this region, your x minus 2 is positive and your x minus 3 is negative. So you multiply positive by negative, and that gives you negative. So in this region, it's going to be negative. That's your f of x. In this region, your x minus 2 is negative and your x minus 3 is negative. You multiply those two to get f of x. So negative times negative, that gives you positive. So that means in this region to the left of 2, your f of x will be positive. Now the question asks, let's go back to the original question. All right. The original question says, so for x, when x squared minus 5x plus x is greater than or equals to. Anything that is greater than or equal to 0 is basically positive. So we're basically looking at points where our f of x is positive. So therefore, f of x, all right, which is basically equals to x minus 2 times x minus 3. Where is it positive? It's greater than or equal to 0. Okay, this is where it's equal to 0. It's equal to 0 at 2, and it's equal to 0 again at 3. But when is it greater than or equal to 0? When is it 0 and also positive? That is to the right of 3 and to the left of 2. So we go, therefore, it is less than or equal to 0 when x is less than or equal to 2. Why do we include a 2? Because that's where the 0 part is satisfied. It's equal to 0 there. That's why. So it is included. Also, the original inequality includes a equal to. So it's greater than or equal to, not just greater than. We're going to look at another example that showcases how we deal with that one. Or when x is greater than or equals to 3, because that's the other region where you've got a 0 and then a positive on the f of x. Now, if you wanted to solve this graphically, this is what would happen. Where is this 0? It's 0 at 2 and 3, because those are your roots of the normal equation. If you were to solve the normal equation, the equation like a normal equation. So there's 0 here. It's 0 here at 2 and 3. But where is it positive? Where is it on the positive side of y? In other words, above the x-axis. It's to this, on this side, it's there, and on the other side, it's this part. This part. And that is how you solve that graphically. Now, how do we solve that in a number line? You've got two critical values, 2 and 3, that are included in the solution. So what you do is you now place solid dots on top of 2 and 3. Let's place the solid dots. Okay, we've got one solid dot on top of 2. Okay, one solid dot on top of 2. And then the other solid dot should be on top of 3. Other solid dot. Okay, let's make it a bit bigger. Alright, here is the other solid dot. Okay, it's on top of 3. Alright, and now it says when x is less than 2, anything less than or equal to 2 will be to the left of 2. So the arrow here will be pointing to the left of 2, because that's where your values are less than 2. And on the other side, anything greater than 3 will point to the right of 3. And that's how you represent that on a number line. Easy peasy so far. Now let's look at the second example. The second example is also still basic and simple. So for x, when 4x squared minus 4x plus 1 is less than or equal to, in this case we're dealing with the less than or equal to. Alright, step number 1, everything is on the left hand side, so we don't need to worry about that. So what we need to do is go ahead and solve. Factorize, in other words. Okay, so we go, alright, 2 sets of brackets, alright, less than or equal to 0. Notice how that is not changing. So you've got 2x and 1, 2x and 1. You can use the formula to help you figure out this quickly. So and then we're going to have minus and minus. That's how you factorize that. Notice that that can also be written as 2x minus 1 all squared. That is less than or equal to. Very important to have it written like this, especially when you've got two factors multiplied together that are identical like this. All right, now let's look at the critical values. Critical values. The critical values here will be easy. It's only one factor that we're dealing with. So we'll have only one critical value, I mean. Therefore, x equals to 1 over 2. Notice how I did not skip a step here. A lot of people make silly mistakes here and jump right directly from this to this and tend to make a lot of silly mistakes, which can make you lose marks during an exam and the test. So I don't advise you do that. I advise you be very careful, do things step by step so that you don't make room for those silly mistakes. Now that we've figured out what the critical values are, let's put them on the table. It will only have one factor, so that's the only thing we will have. So that means we will have only one critical value, right? And then the next one is f of x. Now f of x is very simple in this case. It's just basically the square of this factor. So f of x is the square of this factor, all right? Okay. Okay. Got. Okay. All right. Now we put our critical value. We put our critical value at the top. That is 1 over 2. That is half. Now, 2x minus 1 is 0 at half. So we put 0 there. Now, what happens to 2x minus 1 all squared? 0 all squared is simply equals to 0. So that is also 0 over there. All right. Now, what happens to the right of half? What happens when you substitute a number that is bigger than half? 1, for example. 2 times 1 minus 1 is equals to 2 minus 1, which is equals to 1, which is positive. So it's positive to the right of half, and to the left of half, let's say, for example, put 0. 2 times 0, which is less than half, minus 1 equals to 0, minus 1, which is equals to negative 1, which is negative. So it is negative to the left of half. Now let's see what happens to the function f of x when it comes to the signs. F of x is simply equals to the square of that. So the square of positive will be positive. That's positive times positive. That is equals to positive. So it will be positive on the right hand side. What happens on the left hand side? Minus all squared, negative all squared. That's negative times negative, which is equals to positive as well. So notice that there is no point at which this function f of x, which is 2x minus 1 all squared, is negative. Because when you square anything, it does not matter whether the inside is negative or not, it will be positive, because when you square, you get rid of the minus sign, it becomes positive. So, but there is a point at which it becomes 0, and that will be important because this inequality allows you to also consider 0 because it's less than or equal to. Now, let's see. Draw a simple parabola to help you. For those who prefer a parabola to help you, you draw that. So let's draw that simple parabola. All right. Okay. Here are the axes. No need to draw the axis. In this case, you only have one. In this case, you only have one. It will look up because your a, 4x squared minus 4x plus 1. Your a is positive. Your a is 4, which is positive, so it will look up. All right. We only have one critical value, so that means that critical value means basically if you were to solve that equation, that's where your root will be. Now that's just basically touching the x-axis. It's touching the x-axis. All right, let me draw the axis. So that's where it will touch the x-axis. That's where it touches the x-axis. So that's the part. Everything else is on the positive side of y, and there's nothing on the negative side of y. Now, keep that in mind because this is what the question says. So we need to find the solution to the question. All right, the question was, solve for x squared minus 4x plus 1 is less than or equal to 0. Therefore, okay, f of x, which is 2x minus 1 all squared, all right, 2x minus 1 all squared is less than or equal to 0 when, okay, let's see, using the parabola, when is it negative? Less than means negative, equal to 0, okay, it's 0 at our half here, x equals to half, so that is taken care of. The 0 part is taken care of, but notice that the negative part is not taken care of. There is no part of this parabola that lies below the x-axis. Therefore, the negative part does not apply here. However, the 0 part, which is at x equals to half, applies, and that is the only condition that makes this one true. So therefore, it is when x equals to half. And that is your only solution, because there is no point at any bit or part where the graph lies on the negative side of the y-axis, in other words, below the x-axis. So how do we represent that on the number line? You locate your point half on the number line and you draw a solid dot, because it includes that. That's just the only bit that is applicable, and that's how you indicate that on the number line. It's just simply equals to half. That's the only part that satisfies that inequality. Next question. Now we're looking at a question that will require us to multiply throughout by a negative. Reason being that we're starting out with a negative x squared. Now this makes it difficult for us to factorize. So finding the critical values will be even more difficult, because if we cannot factorize this, then we cannot find our critical value. So what we do is you multiply throughout by a negative. So that's step number 1. Step number 1, you go. Everything else is on the left-hand side, so our job is made easier. So you multiply everything else by a negative sign. So that becomes, okay, negative x squared minus 3x plus 5. Okay. Now, what happens is when you multiply an inequality by a negative sign, it changes the inequality. So in this case, it was greater than, it will be changed to less than. If it was greater than or equal to, it will be changed to less than or equal to. If it was the other way around, it will be changed to the opposite of that. So that's how you deal with the negative, multiplying out with a negative sign. That's the effect it has on the inequality. It changes how the inequality now looks. That will be 0. Now therefore, okay, positive x squared, let me fix that, x squared plus 3x minus 5 is less than, oh, sorry, not equal to, sorry, not equal to, it's just less than, because we do not have an equal to there. So that is less than 0. All right, now we factorize. Notice that we've got our number as 5 here, the last term, then we've got 3 in the middle. There is no way you can find 3 with factors of 5. Factors of 5 are 5 and 1. The only numbers you can find that can make up this is if you subtract the 2, 5 minus 1 will give you 4, or 5 plus 1 will give you 6. So there is no way you can get a 3 in the middle. So what you do is you realize that this one is not going to be easy to factorize. We can still factorize it though, but it's not easy to factorize. So what we do is we use the formula. So you check this into the formula and find out what the root will be, and then take it back to the factors. So we use the formula. The formula says x equals to minus b plus or minus square root of b squared minus 4ac all over 2a, which is equals to minus, okay, a here is equals to 1, and then b is equals to 3, c is equals to negative 5. All right, so that is minus 3 plus or minus square root of, that is 3 squared minus 4, a is 1, c is negative 5, all over 2 times 1. Now that gives you, take out a calculator, Common fraction sign button, okay, and you go negative minus 3 plus square root of, in brackets, 3 squared minus 4 times 1 times negative 5, very important, signs must be kept, and then downward arrow you put 2 times in brackets 1, and that should give you minus 3 plus square root of 29 over 2, which when you use S to D button gives you 1,19. Okay, that's the one root. The one root is 1,19, and the other root will be when you put a negative, a minus. Okay, 1,19, or the other root is to go back to your calculation and change the plus into a minus. Okay, there we go. Change the plus into a minus. Okay, so you go minus 3. Okay, delete minus. All right, and that gives you, that should give you negative 4,19. Negative 4,19. So that gives you negative 4,19. All right, now you go back to your expression there and you use these roots to factorize. So that will be x minus 1,19 times x plus 4,19. That's how you would, okay, that is less than 0. Now your critical values become easy to figure out because we've already figured them out basically. Okay, critical values. Critical values of x minus 1,919 goes to 0, therefore x equals to 1,19. Then the next one, x plus 4,19 equals to 0, therefore x equals to negative 4,19. Now you put these in a table. Okay, let's put them in a table. The first one that comes is negative 4,19 and then the 1,19. Remember, you must list your critical values in ascending order from left to right. So we're going to start with x plus 4,19, and then the next one will be x minus 1,19, and then your f of x, which is basically the product of the two factors. Okay, let's fix that. F of x. Okay. All right. 1, 2, 3. So we've got 2 critical values, 1, 2, so they will fit nicely there. All right, let's fix the table. Okay, sorry. Okay, there we go. All right, now let's put the critical values on the table. That will be negative 4,19, and then the next one is 1,19. Okay, 1,19. Okay, let's fix this one, negative 4,19, and then we've got 1,19. All right. Now, negative 4,19, x plus this, 4,19 is 0 here, and x minus 1,19 is 0 at 1,19. Okay, remember, f of x is the product of the two. F of x is equals to x plus 4,19 minus 1,19. All right, now this is 0x negative 4,19 but positive to the right, because if you put a number that is bigger than this, for example 5 plus 4,19 is positive. All right, that is positive. And then to the left of that, if you put any number less than 4,19, for example 4 minus 4,19, 4 minus 4,19, that is negative 0,19, so it will be negative to the left. And then on this one is 0 at 1,19 but positive to the right. For example, 2 minus 1,19 will give us 1,19, and that is positive, so it will be positive. Then to the left it will be negative. Now for the f of x, the product of the two, positive times positive is positive. In the middle region, positive times negative, that is negative. And in this region, negative times negative is positive, so f of x will be positive over here. All right, now the question goes, the question was like, solve for this if it is greater than. Now we've changed it all up, so we're solving for this when x is less than, so we're looking for when it will be negative. All right, we know that it has two critical values, so if you were to draw the parabola, it will look up, because now that you've multiplied everything by negative, it becomes positive. Your a is 1, so your a is 1, and that is positive, so it looks up. All right, before it looked down, but everything now, because we multiplied out, it looks up. All right, now your critical values will be over here. One on the left hand side, the one on the left hand side will be the negative 4,19. So this is the first critical value, negative 4,19, and the other one on the right hand side will be 1,19. And this is what it looks like. So you've got your x-axis, everything below this point, everything between the roots is below the x-axis, and everything above the roots is on the positive side of the x-axis. Now the question is find x when this is less than 0. Okay, therefore f of x, which is the product of the two, remember, f of x is greater, it's less than 0, sorry. It's less than 0, yes, it's less than 0. It's negative when, let's see, when is it negative? Remember, we're not including critical values because there is no equal to in that. When is it negative? It's negative between minus 4,19 and 1,19. Okay. Or looking at the table, it's negative. This is the part where it's negative on the graph. This is the part where it's negative. Notice that it does not include the point. Very important. So you've got does not include the points. Does not include the points. So the points there, the critical values are not included in this solution. Okay, let's Let me try and minimize that. Let me make it smaller. Okay, let's take it there. Alright, so the critical values are not included. So, and this is so that's when x is less than negative, it's between negative 4,1 and 1,19, because that's where f of x is negative. And this is how you write it when it's between when x is between and not including the extreme negative 4,19, and the other one is 1,19. And this is how you represent that on the number line. You have that negative 4,19, it will be between 4 and 5 there. Negative 4,19. Okay, negative 4,19. There'll be somewhere there. Then you have the other one on 1,19. There'll be somewhere there. Okay, all right. So 1,19 will be somewhere between 1 and 2, just to the right of 1. All right. Now, the region between the two basically is you connecting the two. So to show that it's any number between the two, this is how we show it. So we connect the two hollow dots with a line. And that's how you solve that. That's the graphical solution to it. That is the tabular solution to it. That is the inequality solution to it. And that is the number line solution to it. Next question. Now we're dealing with a rational inequality. So for x, so we're going to start with a rational equation that is identical, almost identical to the rational inequality. So you can see how the two methods differ, and to never make a mistake to solve one exactly the same way as the other, because they're not the same. So let's start with the rational equation. So what we do is, remember, your x must never be equal to 3 or negative 3, because it will make any of the denominators 0. That's making them undefined. We don't need that. That's why the restrictions. Notice the restrictions in the original. X must not be equal to 3 or negative 3. Same for the inequality. Now what you do, step number 1 is you find the lowest common denominator. What is the LCD here? The lowest common denominator is a product of the two denominators. So that is x plus 3 times x minus 3. So what you do is you take this lowest common denominator and you multiply each of the fractions with the lowest common denominator. So you go 2 over x plus 3 multiplied by the lowest common denominator, which is x plus 3, times x minus 3. All right, now these two cancel out, so we have x plus 3 cancelling out with x plus 3. So you're left with 2 times x minus 3 on the left hand side. So that's what you're left with. So you go, therefore, 2 times x minus 3. That's what you have on the left hand side. This is the equation, by the way. You do the same for the right hand side. You don't need to necessarily take everything to the left hand side. It's not necessary with an equation. You can just solve it exactly the way I am solving it. It's much quicker, less of a fuss that way. So now you multiply the fraction on the right hand side with the LCD as well. So we go 1 over x minus 3 multiplied by LCD x minus 3 times x plus 3. All right. X minus 3 cancels with x minus 3, and you're left with 1 times x plus 3. So basically, on the right hand side, you're left with x plus 3. X plus 3. And now, you simply expand on the left hand side. Take everything that is x to the left hand side, and everything that is a number to the right hand side, and voila. So that is 2x minus 6 on the left hand side equals to x plus 3. And therefore, take your x's to the left hand side. So 2x minus x equals to, remember I changed the sign when you cross the border, 3 plus 6 because it was minus 6 on the left hand side. Alright, now 2x minus x, that is x, equals to 3 plus 6, that is 9. And that is your solution. The solution is neither 3 or negative 3, so it is a perfect solution. You're done with the equation. Easy peasy. That's how easy it is to deal with the equation. Now, the inequality on the left-hand side, on the other side, requires something a little different. So what you do is you cannot cross multiply with this one. You don't solve it exactly the way you did with the rational equation, right? So what you do is you now take everything to the left-hand side. That's step number 1. Take everything to the left-hand side, so you have, therefore, 2 over x plus 3 minus 1 over x minus 3 is less than or equal to 0. Now that you've got everything to the left-hand side, you find the lowest common denominator, which is identical to the lowest common denominator of the other one. You find the lowest common denominator, which is x plus 3 times x minus 3. And now what you do is you now put everything on a common lowest common denominator, like you would with any fraction. For example, if you was to solve 1 over 3 plus 1 over 5, you would first find the lowest common denominator, and the lowest common denominator will be the product of the two denominators, which is 3 times 5, which is 15, and then take it from there. So basically you do what you would any fraction. You don't cross multiply, you don't multiply out. What you do is you put everything under the common denominator. How do you do that? You go, therefore, common denominator, x plus 3 times x minus 3. That's on the left hand side. Less than or equal to 0. So now, in order to figure out what you put at the top on the numerator, you multiply each one of the fractions by the lowest common denominator. So we go the first fraction, that is 2 over x plus 3. We'll multiply that by the lowest common denominator, x plus 3 times x minus 3. The x plus 3 cancels out. You're left with 2 times x minus 3. So on the first one, that's 2 times x minus 3. 2 in bracket x minus 3. The next one is minus, okay, let's see. And the next one, we multiply the fraction. The fraction is 1 over 3, x minus 3, okay, multiplied by the lowest common denominator, x plus 3 times x minus 3. And the x minus 3 cancel out, and you're left with 1 times x plus 3. But remember the minus, make sure that you don't mix up the minuses, so that is x plus 3, in bracket x plus 3. Alright, so now you solve as you would any fraction. So on the left hand side now, let's add, so that therefore becomes, therefore, okay, all over x plus 3 times x minus 3 less than or equal to 0. Okay, so when we expand this, this will be 2x minus 6. 2x minus 6, okay, minus x minus 3 when you take out the brackets. Okay, 2x minus x, that is x. So next you go, therefore, 2x minus x, that is x. And then minus 6 minus 3, that is negative 9. Minus 9, so that is your numerator, over the denominator, which is the lowest common denominator. That is less than or equal to 0. Let me just double check the inequality. Less than or equal to 0, that is correct. And now what you do is you now use that to find the critical values. You've got your factors now laid out. We use that now to find the critical values. So critical values. Okay, so we take the first factor, x minus 9 equals to 0, therefore x equals to 9. Next factor, x minus 3 equals to 0. Let me fix this. X minus 3 equals to 0, therefore x equals to 3. Next one, x plus 3 equals to 0. And that is equals to, therefore, x equals to negative 3. Alright, now that you've got the critical values, you draw a table like you would with any other. So make sure that we also align this in ascending order. So we're going to start with the minus 3, then 3, then the 9. So we start with the factor that is connected to that. So that is x plus 3. Then will come x minus 3. Then the last one is x minus 9. That just helps to maintain the order and not confuse us with any of the process when we multiply things out. Then we've got, okay, 3 critical values. There we've got space for 3 critical values, important. Okay, and then the last one is f of x. Remember, f of x is this. F of x, remember f of x, okay, let me fix that. F of x is x minus 9 over x minus 3 times x plus 9 plus 3. Very important. That's our f of x. Okay, let's fix the table now. All right, let's find where each of the factors are 0. We've already figured that one out. Okay, now let's put that on the, okay, we've got the first one is negative 3, then 3, and then 9. All right, negative 3, the first one is 0 at negative 3. The second one is 0 at 3. And the last one is 0 at 9. This one is 0 at 9. Next, we look at where our f of x is 0. Okay, how do we figure out that? Okay, if x minus 9 is 0, okay, when x minus 9 is 0, you've got 0 over something times something, all right, which gives you 0. So that one gives us a 0. Now, watch what happens when any of the other factors at the bottom are 0. So you will have your whatever is at the top. When x minus 3 is 0, this is what happens. You've got a number at the top over, okay, let's make it, okay, let's just substitute. When x equals to 0, you've got 0 minus 9, when x equals to 3, sorry. When x equals to 3, you've got 3 minus 9, 3 minus 9, 3 minus 9 at the top, all over 3 minus 3 at the bottom, and then 3 plus 3, which is equals to negative 6 over 0 times 3. The 0 at the bottom makes everything 0. So you end up with negative 6 over 0, which makes the whole function undefined. And therefore, instead of putting a 0 there, you put a cross to show that the function is undefined when what? X equals to 3. Same story for x equals to negative 3, because when you put negative 3 here, you will have a negative number at the top, but one of the bottom ones will be 0, making the whole thing undefined, so you also put an X here. There you go. Now let's deal with the signs. X plus 3 is 0 at negative 3, but anything bigger than negative 3, for example, 0 makes the whole thing positive. 0 plus 3 is 3, so it will become positive. So we have a positive over here. So that's positive, positive, and positive. And to the left of that, for example, negative 4. Negative 4 plus 3 gives us negative 1, which is negative. So it's negative to the left of that. For x minus 3, it's 0 at 3 and positive to the right of 3. For example, 4 minus 3, that will give you 1. So it's positive. Okay, to the left of that, it's negative because, for example, anything less than 3, that's 2 minus 3 will give you negative 1, which is negative. So it's negative to the left of that. X minus 9 is 0 at 9. It's 0 at 9. And it is positive to the right of 9 because, for example, if you were to put 10 minus 9, that is equals to 1, which is positive. So it's positive to the right. But to the left, it's negative. Let me give you an example. For example, 8 minus 9, that is equals to negative 1, which is negative. So anything to the left is negative. Now the signs are here for the f of x. Okay, here is how f of x is figured out. All right. For each and every one of them, we've got a sign. So for the region here, less than negative 3, this region, okay, our f of x starts with x minus 9, so that is negative, over, at the bottom we've got x minus 3, and that is negative, times x plus 3, and that is also positive, negative, sorry, in this case. So that gives us negative over, negative times negative at the bottom, that's positive, and that gives us an overall of a negative. So it is negative here. Okay, let's use red, it's negative here. Okay, in the region between negative 3 and 3, these are the signs for f of x. At the top, I've got x minus 9. X minus 9 between 3 and negative 3 is negative, so that's x minus 9, that's negative, over x minus 3. X minus 3 in this case is negative. X minus 3 is negative, times x plus 3. X plus 3 in this case, it's positive. Between negative 3 and 3, it's positive. So that leaves you with negative over negative times positive at the bottom, that's negative, and negative divided by negative is positive. So in the region between that, that is positive. Cool. Next, the last region, or the second last region, that's between 3 and 9. Between 3 and 9, x minus 9 is negative. That's what we start with, negative over x minus 3. X minus 3 is positive, times x plus 3 is also positive here, between 3 and negative and 9. That is also positive, so that becomes negative over positive, which is negative. So this region is negative. Okay, let me change the color back to purple because it's clashing with the red here. Okay, so we've got negative and then positive. Alright, we've got negative, then positive. Okay, in this one, that is negative between 3 and 9, that is negative. Alright, and then to the right of 9, we've got x minus 9. Our x minus 9 is positive. So we've got positive over, and then our x minus 3, our x minus 3 is positive, times our x plus 3 is also positive. So at the top it's positive, divided positive by positive, that is positive. So positive divided by positive, that is positive. So that means to the right of 9, it is positive. So, and the question was, find out where this is going to be. Let's go back to the question. Always go back to the question to figure out what exactly they want you to. All right. Find out where this is less than or equal to. Okay. Where that is less than or equal to, that is when it is less than or equal to 0. All this. So f of x, therefore f of x, which is x minus 9 over x minus 3 times x plus 3, is less than or equal to 0. Okay. When is it 0? The only time it is 0 is when your x is equals to 9. But anywhere else it is undefined. It cannot be 0 because it is undefined. So when is it less than or equal to 0? When is it negative? It's negative between this region between 3 and 9, not including 3 because that's when it's undefined, but also including 9. All right. And also another region over here where it cannot be equal to negative 3 because that will make the whole function undefined. So it is negative in this region to the left of negative 3 and in the region between 3 and 9. So let's show that in an answer. So that is when x is less than 9, negative 3, because negative 3 is not included since it will make the whole function undefined, or when x is between n including 9 but not 3. It's between 3 and 9 including 9 because that's when it can be 0, but not including 3 because that's when it's undefined. And that is the solution to that. Now, how do you present that in a number line? So you've got 3 critical values, negative 3, 3, and 9. The only one that we include is 9. That's where we're going to have a solid dot. So we've got negative 3 and 3 and 9, negative 3, 3, and 9. So we've got negative 3. So we've got negative 3. That's a hollow one because it's not included. And then we've got 3, also hollow because it's not included. And then we've got our 9, which will be a solid dot because it is included. All right, and then let's see where we put the lines. So the first one is when x is less than, that's when x is less than negative 3. So the arrow will go to the left of negative 3 in this one. Arrow goes to the left of negative 3. Arrow goes to the left of negative 3, like that. All right, arrow goes to the left of negative 3. All right. So that is the arrow to the left of negative 3. Okay. All right. Now, the other one is between 3 and 9. The other one is between 3 and 9, including 9 but not including 3. So we connect those two. We've already sorted the including and not including. So it's going to be a line, not with an arrow, connecting the two. And that is how you solve this on a number line. Next question, we're looking at an inequality that is a special case of a quadratic or a rational inequality. All right. So now that we've dealt with a rational equation and you've dealt with a rational inequality, you know how not to solve a rational inequality. Let's look at this special case. In this case, we've got x squared plus 4 and x minus 9. There is no way we can factorize x squared plus 4, all right, without encountering any problems. Okay, So there we go straight for our critical values. But before we do, okay, here are the critical values. Critical values. Our critical values are x minus 7. This one is straightforward, equals to 0. Therefore, x equals to 7. This one is straightforward. All right. The next one, though, it's not that straightforward. X squared plus 4 equals to 0. If you are to solve this, then you take everything to the right hand side. That is equals to negative 4. Now, therefore, x is equals to plus or minus square root of negative 4. We know that whenever we're dealing with a square root of a negative number, that means the number is a non-real number. In other words, imaginary, which is imaginary. Okay, non-real. This is non-real. Non-real or imaginary. So we're not going to include it in the number line because it's not a real number. Not a real number. So now we draw the table. So we go x squared plus 4. We include that as well because it's part of the equation inequality. I mean, that's x squared plus 4. All right. Then we've got x minus 7. All right. The only one that basically affects anything is the x minus 7. You will see exactly how. That is the only critical value we have. That is real. And then we've got f of x. Remember, f of x is x squared plus 4 over x minus 7. Keep that in mind. Okay, so that's our f of x. All right, now going to complete the table. Okay, now let's put the critical values. We only have one critical value. That critical value is 7. Okay, now when is x minus 7 0? It's at 7. All right. This one, on the other hand, x squared plus 4 is never 0. Because if you put 0, okay, that will be 0 squared plus 4. That will be equals to 0 plus 4, which is equals to 4. That's bigger than 0. It's a positive number. All right. Now, what happens when we put a negative number? Negative 1 all squared, for example. Or let's put something negative 7, for example. Or negative, that would do. Negative 1 squared plus 4 is simply equals to 1. Negative 1 squared is 1 because that makes it positive. Plus 4, which is 5. So see, this is never negative. It's always positive everywhere. And that helps us with the sign. So this is positive everywhere. Now let's look at the signs of the x minus 7. X minus 7 is 0 at 7 and positive at anything to the right of 7 bigger than 7. 8 minus 7, for example, equals to 1. So that makes it positive to the right. To the left, anything less than 7. 6 minus 7 is negative 1. So that makes it negative. Now the function f of x, on the other hand, is x squared plus 4 over x minus 7. So x squared plus 4, that is positive. So that is positive x squared minus plus 4 all over x minus 7 in this region is positive. To the right of 7, that is positive. So we'll put positive over positive, and that makes it positive. Now to the left of 0, I mean 7, we've got positive divided by negative. Here, positive divided by negative. We've got positive divided by negative. Positive divided by negative, and that is equals to negative. All right. Now, when is this 0? This is never 0, but this is 0 at 7. So at 7, the whole f of x becomes undefined because whatever it is we have at the top, which can never be 0, we will have whatever it is, x plus what at the top, x squared plus 7, or whatever the value might be, all over. Okay, when x equals to 7, this is what we have in reality, actually. That's 7 squared plus 7 7 squared plus 7 all over 7 minus 7. Okay, that is 49 plus 7, that is 56 over 0, and that makes the whole thing undefined, so we have a cross there instead of 0. So it's undefined there. Now the question is, when is this whole thing f of x greater than or equals to? Now notice that it's not easy to draw a function like this because it's not a straightforward parabola or any other function that you've accustomed to drawing by now. So we don't waste our time drawing that function. What we do is we use the table to analyze it. Now we look at f of x. Therefore, f of x, which is basically x squared plus 4 over x minus 7, is greater than or equal to 0. It's never 0, by the way. Greater than or equals to 0 when? When is it positive? Because the 0 part falls away because it's undefined there. Okay. It's positive, in other words, greater than 0 when x is greater than 7. When x is greater than 7. Not including 7, because at the point of 7, that's where it becomes undefined. And that is the solution. How do we present that on a number line? We only have one critical value at 7. So that one critical value will be at 7. All right, the critical value will be at 7 because 7 is not included. So we're going to have a hollow. We're going to have a hollow dot on top of 7. And then the answer says, the question says, when is it greater than 7? It will be to the right of 7. The arrow will point to the right. And that is how you solve that on a number line. And now the last question that deals with special cases of normal inequalities that are quadratic but not necessarily rational inequalities. You have a scenario here where we've got 0 is greater than or equals to x of 6x squared. And then you have a variation of that in all types of variation. Now, the first variation is when we take that and remove the equal to and we leave it as greater than. Next one is when we change everything up, switch it up, and then we'll make it less than or equals to. And then the last one is when we just make it 0 is less than x squared, 6x squared. Now, how do we deal with this? They look all similar, almost identical, but they're not quite the same. They're not exactly the same thing that we're dealing with. Now, how do we deal with that? First of all, we figure out how to solve this by taking everything to the left-hand side. Take everything to the left-hand side. That's step number 1. Therefore, okay, minus 6x squared is greater than or equals to 0. All right, therefore, okay. Now that everything is negative, so we've got minus x squared. Now divide both sides by negative 6. Now what happens is that when you divide, remember what happens when you divide by a negative or multiply by a negative, your inequality changes. So that becomes x squared, positive x squared, is now less than or equal to 0. Because you divided, remember you divided that throughout by negative 6. And I'll show you exactly what happened there. So you went negative 6x squared is greater than or equal to 0. You divided that by negative 6. When you divide by negative 6, that changes a sign and it becomes negative. I mean less than or equal to. And this to cancel out. And then you're left with x squared is less than or equal to 0. All right. That's what happens to the next one. Let's do the same with the next one and the next one and the next one, and then we'll analyze them all at once together. Same thing you do with this one. You go. Therefore, take everything to the left-hand side. Minus 6x squared is greater than 0. And now divide both sides by negative 6. That becomes x squared is now less than, not greater than, it's now less than 6. I mean less than 0. Okay, it's now less than 0. All right. That's what we have as a scenario on the second one. Now the third one, similar story. Take everything to the left-hand side, so that becomes minus 6x squared. It's less than or equal to 0. Now divide both sides by negative 6. When you divide by negative or multiply by a negative in an inequality, the inequality changes. So that is x squared is, instead of less than or equal to, it becomes greater than or equal to 0. Okay, next one, same story. Take everything to the left-hand side, so you're left with minus 6x squared. It's less than 0, all right? Divide both sides by negative 6, and that gives you x squared. Now that changes the sign. X squared is greater than 0. All right. Now the reason why I solved them all together like this is because the critical values are exactly the same. What are the critical values? Critical values for all of these situations are exactly the same. Okay, let's look at the critical values which apply to all of these ones. Okay, so you start with your x squared, so that's x squared equals to 0, therefore x equals to 0. That's a critical value. So you draw up a table, all right? A table here you draw is going to only have one critical value, and the f of x is basically x squared in this case, all right? All right. Okay, the critical value, put it out there, that's 0. Okay, the critical value is 0. Now, when x is equals to, when is x squared equals to 0? Or x equals to 0? X equals to 0 at 0. And x squared equals to 0 at 0 squared. That is equals to 0. So that is also 0 there. All right. Now, what happens to the right of 0 on the first? Okay, x is positive to the right of 0. Any number bigger than 0, it could be 1, 2, 3, or 0, 1, 1, 1, 1, 1, or whatever the case is. As long as it's bigger than 0, we'll make the whole thing to the right hand side positive. On the other side, anything less than 0 will make this negative. For example, minus 1 will make that negative. All right. Now, with the x squared on the other hand, it's positive squared to the right of 0. Positive squared, that is equals to positive times positive. That is equals to positive. So to the right of 0, that is positive. And to the left of 0, same scenario, negative all squared, that is negative times negative, which is equals to positive. So this is positive all throughout. Now, if we were to draw this in a quadratic situation, if you were to draw this parabola, this is what the parabola will look like. In all the cases, this is what the parabola will look like. Okay, so basically just look up, because your a is positive in this case. Your a is 1, so it is positive. So the graph will look up. And you only have one root. You only have one point where it touches the x-axis, so that is it as 0. And that's the only bit that touches the x-axis. Now, if you were to draw the x-axis, this is what the whole graph will look like. That's the x-axis. So everything looks up. It's on the positive y. Nothing is on the negative y. Remember that. Okay, now let's solve this. All right, one by one. Let's look at the first one. The first one, we're looking for a situation where this is either negative or equal to 0. Where is it negative? F of x is never negative anyway. But there is a point where it is equal to 0, and that is when x is basically equal to 0. So in this case, now, on a number line, this is how it would look. on a number line, this is how it would look. You have a solid at 0, solid dot at 0. You will have a solid dot at 0. There is the solid dot, and we're going to leave it as black. Solid dot at 0, and that is the only bit of the inequality that is satisfied when x equals to 0. Now on a number line, not on a number line, but done with the number line, in a graph situation, I've listed all the graphs of each and every one of the scenarios. In a graph situation, the only point where your x is either greater than or equal to 0, I mean less than or equal to 0. Okay, let's point that out. Therefore, x squared is less than or equal to 0. Therefore, x squared is less than or equal to 0. This is the scenario here. X squared is less than or equal to 0. When is x squared less than or equal to 0? It's only 0 here. There is no way it is less than that. So the only point that is applicable is right there when x equals to 0. Okay, at x equals to 0, and that is the solution. At x is equals to 0. That is the solution at x equals to 0. So we write that at x is equals to 0. And that is the solution we write over here as well. So your x is equals to 0 here. That's what you write there. X is equals to 0. There is no space. Okay, let me use a paper. Color x equals to 0. Okay, that's x maps x such that that is equals to 0. And that's it. All right. Next one. Here, the scenario is such that your x squared, we're looking for where x squared, the graph, right, is negative. There is no point where the graph is negative. 0 is not included in this case. So at the end of the day, there is not even a single one that meets the condition. There is no way it is negative and not even equal to 0. So on this one, there is nothing that you can use to indicate. You just leave it exactly. There is no way you can indicate this one. There is no point where it is applicable. So you just leave it like that. And then as a solution, where is x negative? X is less than 0. Okay, when there is no solution. So this is a situation where we say the answer is there is no solution. All right, the next one. Next one, you're looking for where x squared is greater than or equals to 0. You're looking at a point where your graph is either all on the positive or it is equal to 0. So everywhere on the number line, because look, that is applicable to that. So on this one, when you go check it out in the graph, you highlight all the places where that is applicable, and here are the places where that is applicable. Here are the places, it's everywhere on the graph, including your 0. Everywhere on the graph, including your 0. Let me show you. Everywhere on the graph, including your 0. That's where it is applicable. So when you present that in an inequality, you write it like this. You go, this is where x is an element of all real numbers. X maps x such that x is an element of real numbers. There is no restriction here. All right, how do you present that on a number line? All the numbers are valid on the number line. So what you do is over here, you can indicate that you're starting from 0, all right? Let's make it blue because we're dealing with the blue one now. All right, make it a solid blue. So everything is included here. So you've got your number lines pointing on both directions. Sorry about that. Okay. All right, so I need to have my number lines pointing in both directions. Okay, you've got this one pointing this direction to show that you're including everything, any and everything. The other one looking the other side, meaning everything on the number line is included. All real values of x are included here. All right, now number 3 is done. Let's look at number 4. The last one says we're looking for situations where x, the function x squared, your parabola, is on the positive y, but not including 0. In other words, it's greater than 0, not including 0. So in this case, on the number line, your 0 will not be included, so we make it a hollow 0. We're gonna make it a hollow 0. Okay, let's make it a hollow 0. Okay, let's make it a hollow 0, and the color should be changed to 2. The color should be changed to purple. Okay, let's change the color to purple so it matches with the answer that we are applying. Notice that the only one that is not here is the green one, because it's not, there is no solution, it's not applicable anyway. And now, where is this? Anywhere else except for at the point where x is equals to 0. So where is a possible positive but not including 0? Everywhere else except for 0. So your arrows will point down both directions, but not including the point where x equals to 0. So that's the point that is not included. How do we then write that in a solution, an inequality solution? Okay, we'll see that just now. But how first do we present that in a graph where x is greater than 0? I mean x squared, your graph is positive. We're looking at the point where your graph is positive, but the 0 bit is not included. So we'll put a hollow on the 0. We'll put a hollow on the 0. There is the hollow, and it should be purple there to show that 0 is not included there. But everywhere else it is included. So everywhere else is included, because everywhere else it is positive, that is included. So we'll trace that there. Okay, it should be purple. Let me change the color to purple. Okay. Alright, let's fix that. Where else? Except for where it is 0. Except for where x is 0. So everywhere else, that's how you present that in an inequality. Now, how do you write that answer? I mean, in a graph, how do you write that answer in an inequality? So basically, it's everything else. So your x, okay, x is an element of x. Okay, x maps x such that x is an element of real numbers, but x is not equal to 0. That is the only restriction we have here. And that is how you solve all the special cases of quadratic inequalities in a question paper or an exam. We've come to the end of our video. Thank you very much for watching. See you in the next one. Bye.